So in this section, we're going to be looking at linear functions or linear graphs. And I'm going to assume that you have read through the notes up to the example, and that's really important that you've done that. Okay, so assuming that you have, let's look at example 1. So what we need to do in this example is find the gradient of the line, okay, the straight line that passes through the points 3, 2 and 5, 7, and also determine the angle that the line makes with the positive direction of the x-axis. So we've got these 2 points. Now finding the gradient, we use our rule for the gradient, rise over run, which in terms of x and y is y2 take y1 over x2 take x1, and so we label, it's helpful to label our 2 points as x1, y1 and x2, y2. So m equals y2 take y1, that's our rise, over x2 take x1, that's our horizontal run. And so we've identified our x1 and y1 and x2 and y2. We substitute into that rule. 7 take away 2 over 5 take away 3, and that simplifies to 5 over 2, or 2.5. And now the next step is to find the angle that the line makes with the positive direction of the x-axis. And that's the angle that I've marked in here. That's the angle with the positive direction of the x-axis. Okay, that angle there with the right-hand side, not the underneath. Okay, it's always on the top side. Our rule is gradient m is equal to tan theta, and if we rearrange that, theta will equal the inverse operation of tan, sometimes called arctan, of our gradient m. So theta equals the inverse tan of the gradient 5 over 2. Put that into your calculator, making sure that it's set on degrees, and that gives us an answer of 68.2 degrees. The second example here is similar, finding the gradient of the line passing through points 5, -3 and -1, 5, and determining the angle that the line makes with the positive direction of the x-axis. Same type of question, just different points. So let's have a look at those. We've got m is equal to y2 take y1 over x2 take x1. We're just going to identify one of them, those points, as being the x1, y1 and x2 and y2. Okay, make sure you're consistent. So we've got 5 take away -3, which becomes 5 plus 3, over -1 minus 5, and that leaves us with 8 over -4, which is -2. Now, when we have a look at our angle, theta is equal to the inverse operation of tan of the gradient, -2. Put that into our calculator, and what it comes out with is -63.4. Okay, what does that mean? Well, that's the angle in the negative direction from the x-axis, so that's that underneath angle. Okay, that -63.4 means that it's 63.4 degrees underneath the x-axis to the line. Okay, what we want is the top side, because it's always on the top side of the x-axis. So because that's a straight line, we can subtract 63.4 from 180 to give us the angle that we want. And so the angle that the line makes with the positive direction of the x-axis is in fact 116.6 degrees. Okay, let's now look at example 3. We need to state the gradient and the y-intercept of the line 3y plus 6x equals 9. Now in order to do that, the easiest way to do it is to rearrange, so that we've got it in the form y equals mx plus c. So take the 6x over to the other side. So we've got 3y equals 9 minus 6x. And then divide by 3, so y equals 3 minus 2x. Now that it's in the form of y equals mx plus c, we can see that m, the coefficient of x, is negative 2. Okay, the gradient is always that coefficient of x, and that's negative 2. The y-intercept is the constant term, which in this case we can see is positive 3, or y equals 3. This fourth example, we've got to find the equation of the line which passes through a particular point, 3, 2, and has a gradient of negative 2. So we can write down information that we need, which is m, our gradient, that's equal to negative 2, and we use the point 3, 2 by combining those two bits of information into the point gradient formula, y minus y1 equals m outside of x minus x1. So y minus 2 is our y coordinate equals our gradient negative 2 outside of x minus our x coordinate 3. Expand the right hand side, so we've got y minus 2 equals negative 2x plus 6, and then add 2 to both sides so that y equals negative 2x plus 8. And so the equation of the line passes through that point with the gradient negative 2 is y equals negative 2x plus 8. And now we've got example 5. We need to find the equation of the straight line passing through 2 points, 1, negative 2, and 3, 2. So 1, negative 2 is our first point, 3, 2 is our second point. We've got a straight line passing through them. What is the equation of that line? First thing we need to do is to find the gradient. So we've done that before. M equals y2 take y1, and so that's going to be 2 minus negative 2, or 2 plus 2, over x2 take x1, so 3 minus 1. That gives us 4 over 2, which is 2. So our gradient is positive 2. Then we use the point gradient formula, y minus y1 equals m outside of x minus x1. And so we substitute our gradient at any one of the points. Doesn't matter which one we use. So we'll just use the first one. And so it becomes y minus negative 2, or y plus 2. And that's equal to 2 outside of x minus 1. Expand the right hand side. Bring the 2 over to the other side. And we're left with y equals 2x minus 4. Okay, and that's our equation through those 2 points. Now in this sixth example, okay, we've got 2x plus 4y equals 10 as our equation, and the requirement for us is to sketch that graph. Now there's a few different ways we can do it, but the easiest way is to just noting that it's going to be a straight line graph. To draw a straight line, all we need is 2 points. Okay, just 2 points, and then we can draw a line through that. And so the easiest way to get the 2 points is through the x and the y-intercepts. Okay, so we find the y-intercept, and in order to find the y-intercept, we let x equal 0, and then solve for y. Okay, so we're going to substitute into our equation that we have here, x equal to 0. So we end up with the result of 4y equals 10, because the 2 times 0 is 0. Then divide by 4, so we're left with y equals 10 over 4, or 5 over 2, or 2.5. So that's our y-intercept. Okay. We need to approach it the same way for finding the x-intercept. We let y equal to 0, and then substitute into the equation y equals 0. So 2x plus 4 times 0 is equal to 10. It's going to simplify to 2x equals 10. Divide by 2, x is equal to 5. So that's our x-intercept. So then we've got our two axes. We mark on there our two x and y intercepts. Okay, there's our x-intercept at 5 and our y-intercept at 2.5, and then draw a line through those 2 points, and that's our straight line. Okay, it's a sketch, but we mark in those points, labeling the points. It's really important that you label your intercepts so that you're making it clear that you've got that right, using a ruler and just clearly labeling your axes. So here we've got another example where we need to sketch the graph of y equals 2x minus 6. So we'll take the same approach as we did before. We'll find the y-intercept first, and by doing that, letting x equal 0 so that y equals -6. Then we're going to find the x-intercept, let y equal 0, and so then 0 equals 2x minus 6. Rearrange 2x equals 6, and then x equals 3. So we've got our intercepts of y equals -6 and x equals 3. And on our number plane, we need to find those two intercepts and mark them. So marking our x equal 3 and y equals -6, drawing a line straight through them, and that's our graph. Make sure that you label your intercepts as well as the graph, and then we're done. In example 8, we've got two examples where we need to find the size of the angle theta, as we've done before, that the line makes with the positive direction of the x-axis. So both of these equations that we've got there represent straight lines again. So with this first one, we've got y equals 2x plus 3. So what we want to look at that is think, what is the gradient? And we can see by looking at that, the gradient is the coefficient of x, and that is 2. And then we use our rule for the gradient relationship to the angle. So theta will equal the inverse tan of our gradient 2, which when we calculate that out becomes 63.4. The next example we have is 3y equals 3x minus 6. You'll notice here that it's not in the form of y equals mx plus c, so we just need to rearrange that. So we want our y by itself, so we need to divide both sides by 3. And so by doing that, we end up with y equals x minus 2. And we can see from that that our gradient is 1. So using theta equals the tan -1 or inverse tan of 1, we can put that in our calculator and get an answer of 45 degrees.